Okay, so the very last thing that we have to learn how to do is how to solve this problem. We're going to take this problem right here and learn how to use matrices to help us solve it. But before we do that, we need to go over here and review something. So let's take a very simple problem. Let's take, I don't know, 5x equals 10. Now, if I ask you, can you solve that problem? Almost everyone would say yes. And you would say, yes, I can solve that problem because that says 5 times x. So all I have to do to solve that problem is undo that multiplication. What undoes multiplication? But division. So we divide that and we end up with x equals 2. And that's all fine and good. Okay, that's exactly right. 2 is the correct answer to that equation. What if I told you you can't, you're not allowed to divide? Let's say there is no such thing as division anymore. Okay, I took division and I threw it out the window. Can you solve that problem now? The answer to that question is yes. Yes, you can still solve that problem. What you have to do, though, is you have to understand that since we're not allowed to divide, we've got to figure out another way that we can make that 5 go away. And what we have to rely on then is the understanding of reciprocals. Okay? The reciprocal of 5 is 1 over 5. And what's going to happen when we multiply by the reciprocal of 5, we get 1 over 5 times 5 over 1. We multiply top times top, we get 5. We multiply 5 times 1 on the bottom, we get 5. And 5 over 5 reduces to 1. So the exact same thing happens. Okay? You have probably heard, and so those end up being x. This ends up being 10 over 5, which reduces to 2. We get the same answer. Okay? But what you have to understand is what's happening right here when we multiply a number times its reciprocal. We're creating this, what we call the multiplicative identity. And the multiplicative identity is what happens when you multiply two things together and you end up with 1. So what we are going to be working with is not just not just a coefficient times a number, not just a 5x equals 10, but we're going to be multiplying this matrix, and I'm just making this up real quick. We're going to be multiplying this matrix times something that looks like this. We've got to multiply this matrix right here because this is our coefficient. This is behaving the same way that 5 is. There's my variable. There's my constant. We've got to multiply this matrix times its inverse. Okay? We need a multiplicative, let me change this, multiplicative inverse in order to get 1. That's what we need. The multiplicative inverse is whatever we can multiply something together to get 1. So we need the multiplicative inverse of this. Okay? Well, that is exactly what we're going to have our calculators do. And they tell us right here that if you want to find the inverse of a matrix, then you use this button right here. So I think I still have, maybe I don't. I thought I still had Desmos open. But if I go back to Desmos Desmos matrix calculator, and I type in, let's say, let's do matrix A. And let's say it's a 2 by 2, and we type in 7, 5, 1, -3. Okay, and we want to find the inverse of that. then I'm going to go ahead and enter that matrix. And now I'm going to do matrix A, which is that one, and now I'm going to do inverse. Now, the Desmos calculator gives us lots of ugly decimals. I don't really care because I'm not ever really going to have to write that down again. All I want to see is if I multiply A times the inverse of A, is it going to give me this identity matrix? And I know that that looks like an ugly number right there, but that's really 0. They just, it didn't have enough decimal places for it to round off to be 0. But this identity matrix looks like this. So if we multiply one matrix times its inverse, this is the identity matrix, which is the same thing as that Ninja 1. When we get that, when we turn this right here into a 1, that's what the identity matrix is. It's just that 1 right there. So here's what you have to understand. Well, you have to be able to turn this system into this matrix equation. This is very, 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 very important. You absolutely, positively must be able to take this thing right here and write a matrix equation. So this 2 goes right here. This 1, there's a 1 right there, goes right there. 3 goes right here. -4. Notice the -4. The negative comes with the 4. Those are all the coefficients of those variables. So that's why that's called the coefficient matrix. These are the variables, the x and the y, the x and the y. They go right here. And then this one right here, the 7 and the -2, those are the constant matrix. Okay? And so what we're going to do on the calculator is we're going to take, and we're going to enter on the calculator this coefficient matrix, 2, 1, 3, -4. And we're going to say multiply the inverse of that times this side and this side. Well, we don't really have to do that side because we know that this is just going to cancel out with that, leaving me my x and my y all by itself. So all we have to do is type the inverse matrix, the inverse of the coefficient matrix, and multiply it times the constant matrix. Now remember, it has to go in this order because this is a 2 by 2 and this is a 2 by 1. And if we try to multiply matrix B times the inverse matrix, it's going to give us an error. It won't work. So all you have to do is type that in your calculator. And I apologize, I should have already pulled up my calculator, but I think if I go over here real quick, I can pull it up and do that for you on the calculator. All right, so let me see if I can remember what I won't remember, so let me pull this back up. So we were trying to type in, I was going to type in this matrix right here. I'm going to make this a little bit bigger. I was going to hit the matrix button. This is a 2 by 2. Why didn't that work? How come this thing's not working? Uh-oh, it says I've been going too long. So I'm going to stop this right here and finish this problem in a minute.